Welcome to this class. Today I am continuing the chapter Universe of the subject Science and Technology of class 9, and this is part 2. We have divided this chapter into 3 parts, and first part is already finished, and in that first part we were focused on the life cycle of the star. In second part we are doing scientific facts about the universe. I mean to say, there are many things which are found later in this century, in the past 5 or 10 years. These facts are also taken in our book. That's why today's matter is a little scattered. The fact about a planet, the fact about the certain theory, different matters are collected in this part, and we are going to focus on scientific facts about the universe. But before this, at least we have a clear idea about the universe and life cycle of the star. Then we will be able to understand other scientific fact. I want to start with the universe. Look at this. How can we define universe? Universe is a very vast space which contains everything that exists, like galaxies, stars, nebula, planets, satellites, gases, etc. Actually, major component of the universe is galaxy, and each of the galaxy contains billions of stars, and a galaxy may contain numerous number of nebula, and a star may contain certain planets, I mean to say certain non-luminous body which revolves around a star is called planet, and different stars have planets also, and the heavenly body which revolves around the planet are called satellites also present, and gases. Gases is one of the major component of each and every galaxy, because there are huge amount of hydrogen and helium gases present in each and every galaxy. That's why we can say that it is a vast space which contains different matters, whatever exists, and mainly galaxy, star, nebula, planets, satellites, gas. Okay, now I want to show a video clip of the universe. Look at this. It's a very nice video clip. Look at this. These are the galaxies which are moving towards ourselves. Means we are entering into the space far away, more far away and more far away, but it is endless. How big is the universe? We can imagine only. Actually, these galaxies contains millions of stars and other heavenly bodies also, and this is the video clip of the universe. We can just understand how big is the universe. Okay, now in this universe, actually major component is a star. That's why life cycle of a star is taken in our syllabus, and it was taught in detail in previous class. I want to revise a little shortly, and then we'll continue this class. We are now entering into life cycle of a star. This is diagrammatic representation of life cycle of a star, different stages of the star which represents life cycle. Just like human and other animal, a star also born, and it becomes young, and it becomes mature at a time, and lastly it becomes old and it destroys, it dies. And how it occurs, I'm going to show with the help of this diagram. Look at this first diagram represents protostar. This is a huge dark ball of cloud of hydrogen and helium which collect at a place due to gravitational force and forms the protostar. And when the protostar continues its life, actually how it continues its life, the particles of the protostar comes closer and closer to each other due to the gravitational force of attraction, and when they come closer and closer, then temperature rises because of the friction. The initial temperature of this particle are estimated to be minus 173 degrees Celsius, which keeps on rising and rising due to the friction, and a day comes because of huge temperature and huge pressure, nuclear reaction starts in its center. And when temperature rises to 10 to the power 7 degrees Celsius, that means 1 crore degrees Celsius because of the friction, and pressure becomes tremendous, and this under these two conditions, hydrogen contained in it, the nucleus of hydrogen fuses with each other to form helium. And this is nuclear reaction, and this nuclear reaction produces tremendous amount of energy because a part of the mass of hydrogen destroys, and destroyed mass converts to tremendous amount of heat and light energy, and so protostar now illuminates and it emits light, it converts to a star because of nuclear fusion reaction. Look at this is the star. And if the initial mass of the protostar is very huge, then not the normal star, it will form big star or giant star. The size is very giant. Look at the color also, I am showing different. The color of a star represents its surface temperature. If a star appears blue, it means its surface temperature is very high. If it appears white, its surface temperature is less than the blue star. If it appears yellow, its surface temperature will be more or less. The color of sun is yellow. And if the surface temperature is very, very less in comparison with other, then it appears red. Whatever it is, red or blue or white or yellow, but star, in every star, there is nuclear fusion which constantly takes place in its central part, and because of this nuclear fusion, tremendous amount of energy produces, and it emits light and it illuminates. It seems to be twinkling in the night sky. Okay. Now, how long it continues its life? This depends upon the hydrogen gas present in it. How long the hydrogen remains in the star, up to that much time, the nuclear fusion reaction continues. And when all the hydrogen gas present in the star is used up, then what happens? Now a nuclear reaction stops. Actually, a star exists because of the equilibrium force between the nuclear force and gravitational force. Gravitational force tends to pull everything towards the center, but the nuclear force produced due to the nuclear reaction tends to push everything away from the center. These two forces balance each other in a star, and this is called equilibrium of the star. When nuclear reaction stops due to the use of hydrogen, then what happens? Then the inner core contracts more and more due to the gravitational force. Now gravitational force will be dominating force, and nuclear force cannot support, cannot maintain the equilibrium. So the star expands, and it expands and becomes very, very big. At the end of the solar system, in case of sun, a day comes when all the hydrogen gas present in the sun is used up, and it converts to this red giant star. When it converts to red giant star, it expands in such a way that it will engulf the Mercury and Venus. These two planets will be engulfed by this red giant star. It may come up to the Earth also. Okay. Now, after this red giant stage, this is the old stage of the star. Now what happens? This is red giant state, and in the same way big star also forms red supergiant. After red giant stage, the outer envelope now explode, and it is called nova. And after the nova, the left out helium core contracts, and another set of nuclear reaction starts, in which helium nuclei fuses with each other to form carbon, and because of this reason, again it illuminates and appears as white dwarf star, and it is here white dwarf star. This is the remnant of this nova. Nova left white dwarf star. And on the other side, if the size of this star is very big, then the explosion is very huge. And this explosion produces either the neutron star or the black hole. After the supernova explosion, the remaining huge core of helium contracts further and it forms neutron star. Because of the explosion, implosion occurs, and implosion makes it contract. I mean to say helium contracts, and because of this contraction, electrons and protons are pulled in the nucleus and all the mass converts to neutron, and so neutron star forms. A spinning neutron star emits radio waves, and that is called pulsar. It happens if the initial mass of the star is more than 1.44 times and less than 5 times the mass of the sun. Then after supernova explosion, the remaining part converts to neutron star. But if the initial mass of the star is more than 5 times the mass of the sun, then it undergoes very huge contraction, I mean to say disruptive contraction, and the whole mass converts to a point-like mass and it forms black hole. In this way, either a protostar converts to white dwarf, which later becomes fade and fade and remains as a lump of mass in the universe, because when all the helium converts to carbon, then no more nuclear reaction can be produced in this white dwarf. It remains as a lump of mass in the universe. But in case of neutron star, it cannot be seen, it is fade, and the radio waves released by the neutron star can be observed, it is called pulsar. But black hole, this black hole is, there is exactly not any hole at all, but it has infinite density and infinite gravitational force. Even light, when falls on its surface, it will be absorbed and it cannot be seen also. We cannot see the black hole in the sky, but if stars are revolving around nothing, then we can say that there must be black hole in the center. This way we can identify black hole. Otherwise, black hole cannot be identified. When it comes near to a star, it will absorb whole mass of that star. At that time, black hole can be observed. Otherwise, it is not seen in the sky. Okay, this is the life cycle of the star, which starts from protostar and ends at white dwarf or neutron star or black hole. Now, we are entering into some other facts related to the universe. What are they? Now, I want to introduce another word, cosmology. Exactly what is cosmology? This is a part of the science. Cosmology is a branch of astronomy that involves the origin and evolution of the universe from the Big Bang to today and on into the future. It is just related to the evolution of this universe, how universe formed and how it is continuing its life and till what it will continue its life, etc. is studied under cosmology. It is different than astronomy. Astronomy is the study of the objects and phenomena beyond Earth, whereas cosmology is the branch of astronomy that studies the origin of the universe and how it has evolved. This is cosmology. Now, after this, one very important term is there in your book. This is called Big Bang Theory. The whole universe is created by the Big Bang. What is it exactly? What is Big Bang? What is this theory? I want to tell you this. According to Big Bang Theory of evolution of the universe, the evolution of the universe began with an explosion of a point compact mass having infinite density and intense heat called a singularity. Very interesting. There was a point-like mass and it had infinite density and a very, very huge amount of heat energy. That's why it become unstable. And because of its instability, a bang produced, and this is called Big Bang. And because of this Big Bang, the singularity, suddenly the singularity began to expand, and the universe, as we know, is begun. The whole universe is produced by a point-like mass. How dense the mass is, just imagine, and how much amount of heat energy was present in that mass is just we can imagine only. The point mass produced these millions of stars, millions of galaxies, and whole material which we see in the universe. Okay, now after this, I want to show you this Big Bang. Look at this. This is a video clip which tells you about the Big Bang. A small point, when undergoes explosion, then very huge amount of energy produces, and these galaxies are being produced. Look at these are scattering through this point. This way we can imagine about the Big Bang. Actually, this is very interesting matter. Now, this theory is now recognized by the scientists. This is the heat theory, I mean to say, among other theory, this is one of the best theory of this universe, evolution of universe. Now, we have to remember certain point related to Big Bang. The point what we have to remember, this theory is proposed by Georges Lemaitre. This theory is proposed by Georges Lemaitre in 1920 AD. And second, universe originated at about 13.8 billion years ago. And third, it originated from an extremely dense and intense hot point. And fourth, universe is expanding. This is very important. Actually, the distance between the galaxy is found to be increasing. The distance between the stars is also found to be increasing. And this supports the Big Bang theory, because according to Big Bang theory, when bang produced, then what happened? Everything is going away from each other, and this is proved by the increase of the distance between the galaxies. That's why universe is expanding. We have to remember this also. Now next, there is another theory also, Big Crunch. The universe is expanding and expanding and expanding, and a day comes when it stops to expand, and gravitational force becomes dominating force, and everything again comes back to a single point. This is called Big Crunch. According to this theory, the universe will one day stop expanding. Then, as gravity pulls on the matter, the universe will begin to contract. This is called Big Crunch. Actually, the Big Crunch will follow the Big Bang. After Big Bang, Big Crunch. Okay, these are important information. In the meantime, I want to tell you about the Earth also, solar system also. Solar system originated at about 4.6 billion years ago. The whole universe originated at this time, I mean to say 13.8 billion years ago, but solar system formed later. Sun formed later at about 4.6 billion years ago, because the oldest rock and oldest this crystal found on the earth is zircon crystal, and its age is found to be 4.4 billion year by different method, uranium decay, carbon dating. These are the method of finding the age of different rock and minerals. Using different methods of finding the age of the crystal, the zircon crystal is found oldest crystal on the earth. It is of 4.4 billion years ago formed on the earth. That's why this information is also given in our book. That's why I'm talking about this. Now I want to divert to another point, that is geocentric theory and heliocentric theory. The design of the solar system was first explained as geocentric theory, which explains how the solar system is designed and how the universe is designed. And later heliocentric theory came, which explained the same thing differently. According to geocentric theory, this is very old theory, Earth is in the center of this universe, and all the planets and stars are revolving around the Earth. This is very old theory. It was recognized by different sector, all the sectors in the old. This was very old theory and recognized by all. It continued for many years, hundreds of years, many century, and later Nicholas Copernicus proposed another theory against the geocentric theory. It is called heliocentric theory. Heli means sun. Heliocentric theory, according to Nicholas Copernicus, he was Polish scientist. Sun is in the center of the solar system, and all other planets are revolving around the sun in their own path. Sun is in the center, and all the planets are revolving around the sun, and stars are far away, and they are not revolving around the sun. They are very far away. They have their own movement. This was proposed by first Nicholas Copernicus, and it took very long time to establish. I mean to say, the heliocentric theory was not recognized by the people, because in the old religious book it was different. Geocentric theory was written in everywhere in the religious book. That's why it took long time, about a century, to establish the heliocentric theory. Later, the Kepler, another mathematician, this Nicholas Copernicus is also a mathematician, physicist. The Kepler, another mathematician, he traced out the orbit of different planet. This planet is in this orbit, and this is the distance from the sun, was declared by the Kepler. He traced out the orbit of different planets, and later this theory strengthened after the Kepler's the orbital explanation. These two theory, the heliocentric theory is now established. Geocentric theory is now not established. It is gone. I mean to say, this old theory and wrong. Now we are talking about another matter. There are different matter written in your book, and they sometimes cannot be related to each other also. Latest finding declares that there are some planets like Earth, and life may exist over there. This is very interesting. We are searching life in different sectors of the universe, different place of the universe, and scientists are trying to find where life exists. Is there any other planet similar to Earth and life exists over there? They found that this Dorado constellation, it appears like this. It appears like a dolphin. This Dorado constellation has one star. Name of the star is TOI 700, not the D. TOI 700 is the star, and it is red faint star, and it has certain number of planet. One of them is TOI 700D. This is the name of the planet. TOI 700 is the name of the star, and a planet which revolves around this star is TOI 700D, is found to be very similar to the Earth, and scientists compared these two planets. This is the Earth, this is TOI 700D, and there is similarity. What similarity they have? 20% larger than the Earth, it means similar to the Earth, orbits every 37 days. It means it takes very short time to revolve around its own star, 37 days, and receives from it days, and receives from its star 86% of the energy that the sun provides to the Earth. It means what amount of energy we are getting from the sun. If it is compared with this TOI 700D, 86% of the energy which we are receiving from the sun is received by this TOI 700D. That's why its temperature may be moderate for the existence of the life, because the primary matter to exist life is temperature, atmosphere, and oxygen in the atmosphere, and the surface must be rocky where we can walk or we can crawl over there. I mean to say the organism can crawl, and there is atmosphere also, and scientists think that there is water also, and that's why the life is possible in TOI 700D is the latest discussion in the circle of the scientific researchers. This information is given in our book. That's why I'm talking about this. Now, we are talking about the universe. What do you think? Can we measure distance between planets and distance between stars, distance between the galaxy can be measured in kilometer or some other unit of distance which we use on the earth? No, they are very far away. That's why we need some other unit to measure the distance between the planets and distance between the galaxy and star. And so I'm going to introduce those units of distance in astronomy. What unit we are using? Mainly two units are being used. First, astronomical unit, which is shortly AU, represented by AU. What is it? Astronomical unit means, if you are told what is astronomical unit, then don't say one astronomical unit. Astronomical unit is the unit of distance which is used to measure distance of planet from the sun. Mainly, it is used to measure the distance of a planet from the sun. Distance of Earth from the sun is 1 astronomical unit, and distance of Pluto from the sun is 39.5 astronomical unit. That's why this unit is the unit of distance which is designed to measure the distance of a planet or satellite from the sun. Later I'll talk about the 1 astronomical unit. But another unit which is used in the astronomy is light year. What is light year? Don't say 1 light year. Light year is the unit of distance which is used to measure the distance between the stars and galaxies. This is the unit of distance, and it is used to measure the distance between stars and galaxies. But students are a little confused about this. Whenever we ask them what is light year, then they say that distance covered by light in 1 year is light year. No, light year is the unit of distance, and it is used to measure the distance between the stars and galaxies. Now, time came to talk about 1 astronomical unit and 1 light year. What is 1 astronomical unit? We can say this way: the mean or average distance between the sun and the earth is called 1 astronomical unit. It is 1.5 into 10 to the power 8 kilometer. Why mean or average is told? Because earth revolves around the sun in elliptical path, and in elliptical path sometimes it comes a little closer to the sun, sometimes it moves away from the sun. That's why the mean or average distance between the sun and the earth is taken as 1 astronomical unit, and this distance is equal to 1.5 into 10 to the power 8 kilometer. The exact value of this 1 astronomical unit is this: 149597870.700 kilometer. This distance is declared as 1 astronomical unit. But we are not writing this very big number like this. We always use power of 10. That's why we have to shift this point to this place. Means after 1 digit it has to be shifted to this place. It means how many digit left hand side we are shifting this point: 1 2 3 4 5 6 7 8, and 8 digit we are going to shift this point, and if we want to put here, then what happens? 1.49597870,700. Now into, if 8 digit left hand side the point is shifted, then this number should be multiplied with 10 to the power 8, and then this value will be equal to this previous value. If we are shifting towards left hand side, how many digit that goes in power? 10 to the power that. And so this is equal to this. Now this number is also big. There are many digits after decimal point. Normally we will take 1 or 2 digit only. That's why look at this number 1.49. If it is so, then in place, if we remove this 9, if this second digit after point, second digit is if 5 or more than 5, we can take 1 as carry over to first digit, and we can write 1.5, and we can cancel all this number, and we can write this way 1.5 into 10 to the power 8 kilometer. This is average value. And if you want to convert this into meter, then it should be multiplied with 1000, because 1 kilometer contains 1000 meter. So 1.5 into 10 to the power 8 is, if multiplied by 1000, that means 10 to the power 3. Then we'll get what? 10 to the power 8 plus 3 is equal to 10 to the power 11 meter. It means the one astronomical distance is equal to 1.5 into 10 to the power 8 kilometer, or 1.5 into 10 to the power 11 meter. Okay, now let's go to light year. What is 1 light year? Distance traveled by light in 1 year is called light year. It is equal to 9.46 into 10 to the power 12 kilometer. Now I want to tell you a little more about this. Look at this. Distance is equal to velocity into time. And if we have to find 1 light year, then distance is, if 1 light year, then velocity of light can be taken in place of velocity, and 1 year can be taken in place of time to find 1 light year distance. Now this is equal to, velocity of light is 3 into 10 to the power 5 kilometer per second, we know, and 1 year can be converted into second by multiplying 1 with 365, because 1 year contains 365 days, and each of the day contains 24 hours. If multiplied with 24, it comes in day, and if multiplied with 60, then it comes in hour, and if multiplied with another 60, then it converts to second. Now if we multiply all these, then we'll get 3 into 10 to the power 5 kilometer per second into 31536,000 second. And if we multiply this number with 3, then we'll get 94608,000 into 10 to the power 5 is already present over there, and this is second cancel. This is the distance in kilometer. 1 light year is equal to this much kilometer. Now this is again big number, that's why we have to take point after 1 digit here. In between 9 and 4, point is at this place. How many digit we have to shift it to this place? 1 2 3 4 5 6 7 digit. Now we get to 9.4608,000, and it is multiplied by 10 to the power 7, because point is shifted to 7 digit left hand side. So if it is multiplied by 10 to the power 7, this number is equivalent with this number. 10 to the power 5 is already there, and so now we have to reduce the number. We have to reduce the digits here. If 9.46, if we take 2 digit, then third digit is 0. We can ignore all these. So we can write 9.46 into 10 to the power 7 into 10 to the power 5. Same base, that's why power can be added. 9.46 into 10 to the power 12 kilometer. This is the final answer. What I mean to say, 1 light year is converted into kilometer. How can we convert? This way. This is the mathematical procedure with which we can convert 1 light year into kilometer. If you want to get it in meter, then you can multiply this with 10 to the power 3 and you will get in meter also. Okay, let's go through one numerical problem. Now the numerical problem is calculate the time taken by the light in minute and second to come to earth from the sun. Look at this, we have to calculate time not only in second, in minutes and second. Time taken by the light to come from sun to the earth. If the velocity of light, this is known, 3 into 10 to the power 5 km per second, and the distance between them is 1.5 into 10 to the power 8 km. I think you are taught about this. We know the answer, but we have to prove how it comes. I mean to say it is 8 minutes 20 seconds. Light takes 8 minutes 20 seconds to come from sun to the earth, and this is the question we have to prove with this mathematical process. Okay, velocity of light is given, v is equal to 3 into 10 to the power 5 kilometer per second, and distance between sun and earth is also given. Let's say distance is s, and this is equal to 1.5 into 10 to the power 8 kilometer. And what is the question? We have to find out time. Time is what? We have velocity equal to distance by time, or we can say time is equal to distance by velocity, or t is equal to, distance is 1.5 into 10 to the power 8 kilometer, and if we divide it with velocity, 3 into 10 to the power 5 kilometer per second, then kilometer cancel, 3 1s are 3, 3 5s are, point comes. You can use calculator, or t is equal to 0.5 multiplied by 10 to the power 8, and if 10 to the power 5 is taken to numerator, we'll have 10 to the power minus 5 here, and only second is left, it comes in numerator this way. Now I want to continue this. Now t is equal to 0.5 into 10 to the power 8 minus 5 is equal to 10 to the power 3, and this is second, and this is equal to 0.5 into 1000 second. This is equal to 500 second. Now we have to convert this into minute also. That's why this is equal to 500 is, if divided by 60, then it comes in minute. 0 0 cancel. Now say if 50 is divided by 6, then we'll get 8.3333. This is minute, and this is equal to, we can write 8 minute plus, this is also minute in point number 0.3333, and this is minute, and this is equal to 8 minute plus 0.3333. If it is multiplied by 60, then it comes in second. This is equal to 8 minute plus, if we multiply this, 6 3s are 18, 8, carry over 1, 6 3s are 18, 1 19, 9, carry over 1, 6 3s are 18 and 19, carry over 1, 9, and 6 3s are 18 and 19. This 10 is there, 4 digit, that's why 19.9980 second. What it mean? This is equal to 8 minute plus, how many seconds are there? 19.998, it means 20 seconds. That's why we can say that the light takes 8 minutes 20 seconds to come to the earth from the sun. To be clear about the light year, I want to give you some example where we are using it. We can use in different sector of the universe. You know about the Centaurus. It was taught in previous class. This is a constellation, and this constellation contains what? The Proxima Centauri. This is the nearest star from the sun. This is Alpha Centauri. This is Alpha Centauri, and another is Beta Centauri. There is another Delta Centauri, Theta Centauri. Many Centauris are there in Centaurus constellation. And one of them is Proxima Centauri, which is at the distance of 4.246 light year. This is the distance of 2 light year from the sun. This is the distance of 4 light year from the sun, and just near to it, 4.246 light year away, this Alpha Centauri is present. Now I want to tell you this distance, 4.246 light year. Now let's go to another Sirius. This constellation is present in Canis Major. This is one of the constellation. You are taught in previous class also about Canis Major, but we are related with now light year. What is the distance between the Earth and the Sirius star? And it is 8.611 light year. And that's why I can say that Sirius lies at the distance of 8.611 light year. And there is another star also. We are informed about this also. This is in Scutum constellation, and this is the biggest star of the Milky Way, and this biggest star is very far away. It is at the distance of 9459 light year. That's why I can write this value here. This is just the information what I am saying here. These stars are not so far away, but some stars are very far away from the Earth. Okay. Now I think today we finished some facts related to the universe. There were many matter. We started with the universe and the life cycle of the star, and then we entered into cosmology also, and we entered into Big Bang theory, and then I told you about the geocentric and heliocentric theory also, and lastly we are doing this light year and astronomical unit. Now in next class we'll meet with some other subject matter. Today's class is over. Thank you.